Let's look at this problem. All the roots of the polynomial, this one, this order 6 polynomial, are positive integers. All of the 6 roots are positive integers, possibly repeated. What is the value of b? This coefficient b. Good. So basically this problem reminds us of the Vieta formula right away, right? Because it'll tell you something about the roots, and the question is about the coefficients. Therefore, let's go to the Vieta formula right away. So let's assume the 6 roots are z1 all the way up to z6. We have 6 roots for a 6th order polynomial. And then by Vieta theorem, we know that since we know this 10, right? That's the coefficient of the 2nd order. Therefore, the sum of this zi equals 10. And then the constant term is 16. Therefore, we know that the product of these 6 roots is 16. And let's rewrite it in this way, 2 to 4. Let's factorize it. Nice. Now the question is about this coefficient b. Then what is the value of this b in terms of these roots? So we know that that equals the sum of the product of any 3 different roots, zi, zj, and zk, and I not equal to j not equal to k. This is not a good notation. It's just for simplicity. It just means any pair are not equal. And what is the sign of that? So we know that by Vieta theorem, the signs are alternating. So the first is negative, and then positive, and then negative. Therefore, we have a negative sign here. So let's put it here. This will simplify our writings in the following derivation, and we will see. Okay, so now in order to calculate this b, or negative b, we have to know something about these zi's, right? And certainly these 2 equations are not sufficient or not directly applicable. We have to solve these zi's individually. And let's start from the extreme case. Particularly we like this, right? Given that these zi are positive integers, then we can do a casework to find out what are they. So let's start from an extreme case. In the case 1, let some zi, let's say z1. Let's assume that z1 is the largest. So what about z1 equals 2 to 4, right? Because all zi's should be a factor of this 16, or 2 to 4th. Therefore, z1 equals 2 to 4, which is 16. We know it's certainly wrong. That's not possible, because we know that the sum is 10 and all 6 roots are positive integers. So we can have a root that is greater than 10 already. Then in the next case is z1 equals 2 to 3, and which is 8. We know that this is wrong as well. Remember, we have 8 positive numbers, positive integers, which adds up to 10. And if one of them is already 8, then the sum is certainly greater than 10. Therefore, this is impossible. What if z1 equals 2 squared, which is 4? Is this possible? Let's subdivide it into 2 smaller cases. Remember, we have another 2 copies of 2, right? Because here is 2 to 4. One subcase is 2, 2. We have 2 copies of 2's, and then 3 1's. Is this possible? So if you add them up, you get 11. So that's wrong. Then how about we put these 2's together? Then that's 4, right? Then the next 4 roots have to be 1, 1, 1, 1. And we know this is wrong as well. If we add them up, they are 12. Therefore, the only choice left is the zi, the maximum root is 2. Therefore, the zi I equals 1, 2, all the way to 6, they have to take values from 2, 2, 2, 2, 1, 1, right? 4 2's and 2 1's. And let's check this. Do we add them up to 10? Yes, they do add up to 10, right? Therefore, we know that out of the 6 roots, 4 of them are 2's, and 2 of them are 1's. Then let's come back to this formula for b. This summation, we know that it's not complicated, but we have a lot of terms in it. So is there a systematic way that we can do the summation? The answer is yes. In here, we still do the casework. Since we have more 2's than 1's, so let's start from 2's. What if all 3's are 2's? Then we have 4 choose 3 possibilities, right? And each copy of that takes a value of 2 to 3, because we need to multiply them, right? So that's one case. The next case is we have 2 copies of 2's. Then that's 4 choose 2. And then 1 copy of 1. Since we have 2 1's, so we have 2 choices. And then for each copy, the product is 2 squared times 1. So we just skipped 1. And the last case is we have 1 copy of 2 and 2 copies of 1. So in that scenario, that's 4 choose 1 times 2, because each copy of that is 2, and we have to take both ones. Good. So negative b equals this. So let's do the calculation. So the first 4 choose 3, that's 4, which is 2 squared, and that's 2 to 5, plus 4 factorial over 2 factorial, 2 factorial, 2 times 2 squared. So the 2 factorials cancel out with this 2 squared. Then we have 4 factorial times 2 left, and we leave the calculation to the next step. Then the last item is 4 choose 1 is 4, then that's 8 times 2, right? So this equals, the first term is 32. The second term is 4 factorial is 24 times 2, that's 48, plus 8. So these two gives 80. Therefore, our final answer is 88 for negative b. So b equals negative 88. Therefore, A is our choice. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.